Now, question 48, you could well be asked to do a question like this on an assignment, or maybe even a test or an exam, algebraically. Now, this is how we would progress. We're given two pieces of information about this geometric sequence, the third term, which is a times r squared, which is 48, and we're given information on the eighth term, which is a times r to the 7, which is 1356, or some people like doing it this way. I'm not really that keen on it. That's T3 times r to the power of 5. Now, when I divide T8 by T3 using some simple index laws and a bit of division, the a's cancel, the 7 minus 2, so it becomes r to the 7 minus 2, and I've done that division, which is 32. So r to the 5th is 32. Now that's not really an answer. I've really got to raise both sides to the power of 1/5 in order to undo this situation so I can find r. So what I do on my calculator, I get 32 and I raise it to the power of 1 divided by 5. And that will give me a common ratio of 2. Now, algebraically, I can substitute r is equal to 2 into T3, which is a times r squared. So therefore, a times 2 squared is 48, a times 4 is 48, and a pretty quickly is found as 12. So therefore, the expression for t to the n is equal to 12 times 2 to the power of n minus 1. Now, there's a fair bit of work in that, and it probably is perhaps some of the hardest work we actually do in the entire course. So as an alternative, you can actually make use and kind of fudge things a little bit using your calculator and the keyboard functionality you've seen before. So this is what I'm going to do. I'm going to enter a times r squared is equal to 48, and a times r to the 7 is 1535, and solve that for a and r. Now, I would interact that probably around about here. If it says algebraically, it's kind of a fudge, but this might shorthand or shortcut at this point. So I'll just quickly put that in here. So it's a times r, use your keyboard there. So I'll make sure I've got the right functionality. So a times r squared is equal to 48, and a times r to the power of 5 is power of 7, I should say, sorry, is equal to 1535, and I'm solving for a comma r. So you can see in that instance I end up with 12 and 2. I'll just put that down. So a is equal to 12 and r is equal to 2. So working through that, I would still find the same equation. I'll just move on in a moment and solve the rest of the question with you. So just finishing off this question, I'm after the 12th term. So 12 times 2 to the power of 11 will give us 24576. Now you might like to check to see how you can find that using the sequence generator on your calculator as well. And when you do that, you'll see you get the 24576. I tend to, by default, leave my sum or series table column open as well, It's a habit I'm into. It's something you might choose to do as well.